Welcome back, everyone. We are on day 22 of MAT 2150, covering chapter 5.1. And today we'll be discussing supply versus demand functions as an application of integration. First, some prerequisite material. Let us consider two functions. Here we have two lines, and I'd like to consider the graph of these two lines and to find their intersection point. Now, since the slopes of these two lines are 2 and minus 3 respectively, they're not parallel and hence they must intersect somewhere. The first will have a y-intercept of minus 1 and a positive slope of 2. And the second has a y-intercept of 4 and a slope of negative 3. And thus, we must have some intersection point here. Notice, for this intersection point, it is an ordered pair. Therefore, it must have the same y value and x value regardless of the function f or g. So how will we find this x that corresponds to this y? We will say, hey, they must have the same y value. Therefore, we set the two functions equal. They must have the same height at this point. Now we can solve for the x where this is true. Now it's fairly basic algebra. Let's add 3x to both sides to get 5x minus 1 is equal to 4. Now let's add 1 to both sides to get 5x is equal to 5. And now divide by 5 on both sides to get x is equal to 1. Therefore, our intersection point here is the ordered pair 1, comma, question mark. Oh, well, what do we actually get? Now we can take either function, it doesn't matter which one, since they're equal here, and plug it back in. We'll get this y value by computing, say, f of 1. That is 2 times 1 minus 1, or 2 minus 1, or 1. Now we know that this ordered pair is 1, comma, 1. Now let's put that idea in context given some supply and demand functions. First, what do we mean by a demand function? Output of this function is the price for some product that consumers are willing to pay when X number of units of that item are produced. S is the price in dollars that producers are willing to accept for that product given that X units are produced. Now we can find the equilibrium point. This would be the ideal price for both the consumers and the producers, where the demand is equal to the supply. Then we will find the total expenditure. We can think of that about as how much money the consumers spend when they spend the amount of money that corresponds to the equilibrium point. Then, once we have our total expenditure, we can compute the consumer surplus and the producer surplus by making a comparison of the area under the curves. And we'll write that down geometrically once we get to those parts. Let's first find the first two parts. Let's find the equilibrium point. Remember, these are just graphs of two functions, so let's graph it first. Let's see visually where our equilibrium point will be. It it corresponds to the intersection point of these two graphs. We can see that they do intersect. It looks like it's at about at 2. Let's verify that by setting the two functions equal. We set the demand function equal to the supply function. This will be the price point, which is most beneficial to both the consumers and the producers. So we set minus 3x plus 12 equal to 2x plus 2. Now we can do the algebra to solve. Let's add 3x to both sides. And now let's subtract 2 on both sides. Finally, let's divide by 5. It says 2 is equal to x, or x is equal to 2. Now we verified that the equilibrium point we read from the graph is correct. Now we know the x value, and we need to find the corresponding y value. We can use either function. I'm going to use the one without the minus signs. We can say that the y value for our equilibrium point will be s of 2. Now that's equal to 2 times 2 plus 2, or 4 plus 2, which gives us 6. Now we know our equilibrium point is 2, 6. Now let's think about part B, keeping in mind we know that the equilibrium is 2, 6. Now what do we mean by the total expenditure? Let's assume that the price that will be set will correspond to the equilibrium point. Then the price is the height 6. The number of items produced is 2. So if all of those items are indeed sold, then the amount of money spent on that many items corresponds to the area of this rectangle. Because price of an item times the number of units is the total cost. So keeping in mind that our equilibrium point was 2, 6, we know the price was 6, and the total number of units was 2, and hence we'll get a total cost of 12. Now for part C, the consumer surplus. Let's again, on our graph, place our equilibrium point. And draw the rectangle which corresponds let's shade that area, and let's see, what does it mean geometrically, this integral minus this quantity? Remember that Q times P is represented as the product of 2 times 6, which gave us 12. So if we take the area under the curve of the demand function and we subtract this rectangle, then that leaves us with this area on top. Remember, the demand function tells us the price that consumers are willing to pay. The multiplication of Q times P tells us the amount of money that consumers actually pay given the equilibrium point. So this is why we call this the consumer surplus. This is the amount of money more that the consumers were willing to pay, which is represented by this area. Now we can write this down. We have our ordered pair. Q comma P is 2 comma 6. Therefore, we're integrating from 0 to 2 the demand function, minus 3x plus 12. And then we subtract the multiplication, Q times P. We subtract 12. Now we can apply our fundamental theorem of calculus and find the antiderivative of minus 3x plus 12. That should give us minus 3x squared over 2 plus 12x, and we evaluate that in between 0 and 2. So we plug in 2, then we subtract when we plug in 0. That gives us minus 3 times 2 squared over 2 plus 12 times 2, and then minus 0. Now let's not forget this subtraction by 12, and let's simplify to find our final answer. Here we have 2 squared, which will cancel with one of these. So we're left with one copy of 2. We get minus 6 plus 24 minus 12. Or 24 minus 18, which gives us 6. So now we know the total area which lies above this rectangle, which gives us the surplus of money that the consumers were willing to pay versus the equilibrium point. Now let's find our producer surplus. Again, it's defined by this integral. Let's first start by drawing our equilibrium point and the corresponding rectangle. That corresponds to this area. Now if we take the area of this rectangle and we subtract the area under the curve, of S, then that will leave us here with this small region of area and you can see why we call it the surplus. This is the price that producers were willing to charge for X units produced, and this is the price that they actually charge given the equilibrium point. And so the difference of those areas represents the price above the producer curve and gives us the area of this triangle remaining. Now let's compute this quantity again. First, we start with Q times P, and Q P was this ordered pair, 2 comma 6. The multiplication gives us 12. Then we integrate from 0 to 2 the supplier price index. So we do 12 minus the integral from 0 to 2 of 2x plus 2. That gives us 12 minus 2x squared over 2 plus 2x evaluated in between 0 and 2. That is 12 minus 2 times 2 squared over 2 plus 2 times 2. Now let's simplify. We can cancel a 2 here and do these multiplications. Don't forget our parentheses. Here we have 2 squared, which is 4, plus 4. That is 12 minus 8, which leaves us with 4. Now let's try another example here, given a slightly more complicated looking curves. Again, we have our demand function, the price consumers are willing to pay, and the supply function, the price that the suppliers are willing to charge for X units produced. So here we can see, given the graph, we do have an equilibrium point which corresponds to the intersection of these two curves. And so we find that intersection point by setting these two functions equal. Now let's see, what can we do? Looks like maybe we need to expand the left-hand side. Let's FOIL this. We should get x squared minus 16x plus 64, and that's equal to the right-hand side. Now, let's simplify as much as we can. Let's subtract x squared on both sides. Now let's add 16x on both sides. So we get 64 is equal to 20x plus 24. Now we can subtract 20 on both sides. And we'll be left with 40 is equal to 20x. Now divide by 20 and we get x is equal to 2. Now we can draw the rectangle which corresponds to the total expenditure. Our total expenditure, assuming that the price will be set corresponding to this equilibrium point, is the amount the consumers are willing to pay for that many items produced, and is represented visually by the area of this rectangle. So we know the number of units produced will be 2, and we need to figure out what is this height, which we can get by plugging this back into either function. Let's use D. Plug it back in. We get 2 minus 8 squared, that is minus 6 squared, which is 36. And so our total expenditure corresponds to the area of this rectangle, which is 2 times 36, which gives us 72. Now let's find our consumer surplus, and let's draw the picture which corresponds. We have our rectangle corresponding to the equilibrium point, and we know this rectangle has area 72. Our consumer surplus is the area underneath the consumer price curve, which visually gives us the area of this region. Our equilibrium point is QP, which is 2,36, and that multiplication gives us 72. So we take the integral from 0 to 2 x minus 8 quantity squared dx. Then we subtract 72. Now we can apply our power rule. This becomes x minus 8 quantity cubed over 3. The value weighted in between 0 and 2 minus 72. Now we can do the evaluation. Plug in 2. That is 2 minus 8 cubed over 3 minus 0 minus 8 cubed over 3 and then minus 72. Now let's simplify that. Here we will have minus 6 cubed. Six cubed is 216 over 3 is 72. Here we have a minus with the minus. Since this is cubed, that minus will survive. So we have 8 cubed over 3. Let's see, that is 512 over 3. Since it's minus with a minus, get a cancellation, and then we have minus 72 here. So these two cancel, and we're left with 512 over 3. Since we have a price, let's go ahead and do the division and round to 2 decimal places. Therefore, we have 512 over 3 gives us 170.67. Now let's find our producer surplus. Again, we start with drawing the same picture corresponding to the rectangle given the equilibrium point. Now this integral takes this rectangle and subtracts away the area underneath the supply price curve. So let's try a different color here. Here's our rectangle corresponding to the total expenditure given the equilibrium point. And then we take away the area under the curve of our supplier price function. That leaves us with this little chunk of area, which represents the amount of money more that the suppliers should expect to make given each price point. So now let's evaluate our integral. We start with the area of our total expenditure and we subtract the area under the supply curve. That is from 0 to 2 x squared plus 4x plus 24 integrated with respect to x. So let's find our antiderivative. We get x cubed over 3 plus 2x squared plus 24x, and we evaluate in between 0 and 2. Now we plug in 2 cubed over 3 plus 2 times 2 squared plus 24 times 2 minus 0 . 2 cubed, that's 2 times 2 times 2, gives us 8 over 3. 2 squared is 4 times 2 is 8, plus 48. Now let's simplify. We have 72 minus 8 over 3. Let's not forget our parentheses here. We need to subtract all of those terms, minus 8 and minus 48. Let's see, calculator error. Let's try that again. 72 minus 8 over 3 minus 8 and minus 48. There we go. I got 13.33, which we will round off just by chopping off to 13.33. Now let's introduce a new idea. We will confine the consumer and producer surplus once we find the equilibrium point, but then we will also consider a maximum price or a price ceiling. This is a maximum price that we're allowed to set for either curve. And then we'll find the corresponding points on the curve corresponding to this maximum price. With that, we will be able to find the new consumer and new producer surplus, which is the surplus with a price ceiling, and then find the deadweight loss. The deadweight loss is a comparison of the loss and surplus when we set this cap versus the price of the equilibrium point. Let's first find our equilibrium point for these two demand and supply functions. It again corresponds to this intersection point. Hard to read from the graph, so we'll have to do this one algebraically. We take our demand function and we set it equal to the supply function. That is 500 minus x is equal to 300 plus 10x. Now we can subtract by 300 and get 200 minus x is equal to 10x. Now we can add x to both sides. We get 200 is equal to 11x, and therefore x is equal to 200 divided by 11. Now we can take that and plug it into either point. We know the x value is 200 divided by 11. Let's use our demand function, plug it in and see what we get. And here a decimal will be okay. Let's see, 500. Let's do it exactly first. We just take 500 and subtract. 500 minus 200 over 11. So that is 11 times 500, or 5,500 minus 200 divided by 11. Now we can do that subtraction. It's 200 over 11, comma, 5,300 over 11. And now we can get decimals for both of those. 200 divided by 11, 18.18. 5,300 divided by 11 is 481.81. Interesting symmetry there. 18, 81, 81. Now let's find our consumer and producer surplus. Let's see if we can stretch out this picture here. Let's make it a little shorter and a little wider. Now let's draw the rectangle that corresponds. Here's our rectangle that corresponds to the equilibrium point. And now the consumer surplus is given by this additional area, which falls under the demand curve, but above our rectangle here. First, what is the area of our rectangle? That's 481.81 multiplied by 18.18. And multiplication of Q times P gives us 8,760.32 cents. And now the area that we're interested in will be given by the integral from 0 to Q of S of x dx minus Q times P. That is 0 to Q, 300 plus 10x dx minus 8760.32. Now we can compute our integral. We get 300x plus 5x squared. That's 10x squared over 2, which gives us 5x squared, integrated from 0 to 18.18. I get those in the right order? Yes, 1818 was the units produced, and 481.81 was the price. You know, maybe from the start here, we should have rounded to 18. Because what does it mean to produce 0.18 unit of an item? So keep that in mind. Maybe we should have rounded that one from the start. Either way, it doesn't affect our answer much. We just multiply 18 times the price rather than 1818. Let's go with our decimal since we've already started, but keep in mind you may need to round that given the physical interpretation. It doesn't make much sense to produce less than 1, between 0 and 1 of an item. here we get 300 times 1818 plus 5 times 1818 squared. And then we need to subtract this quantity. Uh-oh. So let's let our calculator do that one for us. We have 300 and 1818 plus 5 times 1818 squared. And then minus 8760.32. Well, that's not good. We got a negative number. Oh my goodness. We did something silly here. We've actually jumped ahead and found the producer surplus, which means that instead of subtracting this number, I should be taking that number and subtracting this integral. We found our producer surplus first. Which means we take this quantity that we found and subtract it from Q times P, which should give us a positive number. And that gave me 1653.76. Now let's play the same game and find our consumer surplus. Let's make sure we adjust our picture to correspond with the color. What we just found was the area here of this shaded region. Now what we'll find will be the area here of this shaded region. Now we take the integral from 0 to q of d of x dx minus q times p. That is the integral from 0 to 1818 of 500 minus x minus 8760.32. Now we can find our antiderivative of 500x minus x squared over 2. Now let's do the evaluation. Let's see if we plug in 1818 times 500 minus 1818 squared over 2. I got 8,924.74, and then we subtract 8760.32. And I got 164.42. So now we've found both the consumer and the producer surplus. Next, we're going to find the price ceiling. What we've done is set a maximum price of $472. And so here, let's find 472. That would be somewhere right in here. So let's plug that back into our supply function. Let's see. Here we have our equilibrium point, which was 1818, 481.81. And now we have this new price maximum set to protect the consumers, which means the price can be set no larger than 472, which is going to lie somewhere down here on this curve. Let's say right about here. And so now we want to find this ordered pair we'll call X sub C, P sub C, which is the units produced and the price corresponding to our price ceiling. Of course, we already know what the Y value is. The only question is, what is the corresponding X value? Our maximum price is 472. Now, how many units are the producers willing to produce at that price point? We take 472 and set that equal to our supply curve. That is 472 is equal to 300 plus 10x. Now we can do the subtraction. 472 minus 300 gives us 172. And now we can divide by 10 to get 17.2. Which ideally we could think of as 17, 472. And like we did before, we can draw the corresponding rectangle. Where the area of that rectangle is given by the product of the number of units produced multiplied by the price point for that number. Gives us 17.2 times 472. Times 472, or 81184. Now that we have our price ceiling, we can find the new consumer and producer surpluses. And here's our adjusted formula to find exactly that. We take our price and the number of units corresponding and do that multiplication. We take the area under our demand curve and subtract that quantity. Let's draw the picture which corresponds. X sub c, P sub c was here, which gives us the area of this rectangle. Then what we're actually finding by this integration and subtraction is the remaining here area here under the curve, but above that rectangle. So let's find our new consumer surplus. Here we do the integration from 0 to 17.2 of 500 minus x dx, and we subtract $8118.4. So we get our antiderivative like before, 500x minus x squared over 2, and we evaluate in between 0 and 17.2, and then we subtract 8118.4. When we do this evaluation, I got 8452.08 minus 8118.4. And that gives us the new consumer surplus of $333.68. Now let's find our new producer surplus with a similar strategy. Here is our nice adjusted formula. Uh-oh, skipped one. Oh, go back. No, we didn't skip a slide. There's our consumer surplus. Now let's find our producer surplus. We need to adjust our formula though. Instead we integrate S, and instead of subtracting here, we take that quantity xp p sub b sub c, and we subtract here. So let's first draw the region that corresponds to this integration. This is the area of this rectangle which falls above the supplier curve. That gives us this remaining area, which is the producer surplus given the price cap or the price ceiling. Here we can evaluate this as 8118.4 minus the integral from 0 to 17.2 of 300 plus 10x dx. That is 8118.4 minus 300x plus 5x squared, evaluated from 0 to 17.2. Now let's do that evaluation. And I got 1479.2. Now our goal is to find the deadweight loss. Let's first draw the picture that corresponds to that quantity. Now we both have the points corresponding to our price cap and the equilibrium. So here we have P sub C, here we have X sub C, P sub C. Now those gave us these rectangles. And now, given the price cap, there's all this additional area between these two curves. And it's this region that we're going to call the deadweight loss. The loss in the price of the demand versus the producer, given that there was the price cap, versus the equilibrium. That this area of this region is given by this integration. So let's first recall what were our points for the equilibrium. It was 18, 18, and 17.2. And so we're going to integrate from 17.2 to 18.18. The demand function, which is 500 minus x, minus the supply function, being extra careful here to distribute this negative sign, those so that we subtract the entire supply function. So now simplifying, 500 minus 300 or 200, and minus x minus a 10x or minus 11x. Now we can find our antiderivative of 200x minus 12x over 2 and evaluate that from 17.2 to 18.18. Let's do that evaluation. Here I got 386.698. Let's try another example here, given our price ceiling. First, we'll take our demand and supply functions and find our equilibrium point. That corresponds here to the intersection of these two graphs. Here we set 209 minus x equal to 34 plus 0.4x. 209 plus 34 gives us 243. Add x to both sides, and we get 1.4x. Now we divide both sides by 1.4. And we get 173.57. So that means our equilibrium point here is 173.57. We can find the corresponding y value by this subtraction, 209 minus 173.57. That gives us 35.43. And now let's find the point which corresponds to our price cap. I see an error here. Let's go back. Let's try that again and check our algebra. First we said 209 minus x equal to 34 plus 0.4x. Now we need to subtract by 34. Which gives us 175. And add x, which gives us 1.4 times x. Now we divide by 1.4, and that gives us 125. Now we know the x coordinate corresponding to our equilibrium point is 125. Now we can do the subtraction, 209 minus 125 to get our price for the equilibrium point, which is 84. Next, let's find a point which corresponds to our price cap. Here, we're given the price cap is $58. So we take our supply curve, and we're going to price the price cap at about $58, and we need to find the corresponding input. So we take our supply function and we set it equal to 58. That is 34 plus 0.4x is equal to 58. Now let's subtract by 34. Let's see, take away 4, that's 54. Take away 30, that's 24. So 0.4x is equal to 24. And hence x is equal to 24 divided by 0.4. Let's see, that's 4 over 10, so that gives us 60. So over here was our equilibrium point, and here is our point corresponding to the price cap. 125.84. And here we have 60. Or 58. Now we can find our new consumer surplus. Remember that that corresponds to the point given our price cap. visually is represented by the area here between the demand function and the rectangle corresponding to our price cap. That gives us the area of this region. So we need to compute the integral from 0 to 60 of 209 minus x dx, and then minus 60 times 58, which gives us 2,900. Is we find the antiderivative, 209x minus x squared over 2, evaluated from 0 to 60, and then subtract 2,900. Now we plug in 60. Let's see, what do we get when we do that evaluation? That is 209 times 60 minus 60 squared divided by 2, and then minus 2,900. Here I got 7,840. Now let's find our new producer surplus. Here we have our point corresponding to the price cap, and we're going to compute this multiplication minus this integral, which gives us the area of this region. That is, we compute 2,900 minus the integral from 0 to 60 of 34 plus 0.4x. That gives us 2,900 minus the antiderivative is 34x minus 0.4x squared over 2, evaluated from 0 to 60. Now we can plug in 60. $2,900 minus 34 times 60 minus, with a minus becomes plus, 0.4 times 60 squared divided by 2. And here I got 1,580. Lastly, let's compute our deadweight loss. Again, we have our points corresponding to the equilibrium point and the price cap. And hence the deadweight loss is the area here where this curve is the price the consumers are willing to pay, the demand function, and this curve is the price that the suppliers are wanting to charge. Given the price cap, we have all of this excess area. We can consider this as loss versus the price consumers are willing to pay versus the price the producers will pay or will charge, given that there is a price cap, which is why we call this a deadweight loss. the difference between these curves given that the price can be no bigger than the price cap. So let's set up our integral here. We need to integrate from 60 to 125, 209 minus x minus the quantity 34 plus 0.4 x dx. Now let's see. Let's first simplify. That is 209 minus 34. It's 175. Then we have minus x minus 0.4x or minus 1.4x dx. Now we can find our antiderivative. That is 175x minus 1.4x squared over 2, evaluated from 60 to 125. Lastly, we can do the evaluation. We plug in 125 and we subtract when we plug in 60. I'm going to let the calculator do that one for me. And I got 2,957.50. Lastly, I'll leave you with this image, which is a nice summarization of all of the talking points that we've considered today. This might be a good picture to take a photo of, take a screenshot of, and keep in mind as you're going through your homeworks, so you can keep in mind what regions correspond to each of these definitions. That ends our lecture for chapter 5.1. We'll see you next time.